Hey there, my name is Alejandro, and welcome back for day 170 of me doing the Daily LeetCode challenge until I reach 1 year's worth of green contributions here on GitHub. So today is promised for January 2nd, 2025, and without further ado, let's get straight into it. Okay, today we get LeetCode medium problem 2559, count vowel strings in ranges. You are given a zero-indexed array of strings words and a 2D integer array of integers queries. So, okay, zero-indexed array of strings words and a 2D array of integers queries. Okay. Each query's L to R asks us to find the number of strings present in the range L to R, both inclusive of words that start and end with a vowel. Okay. Start and end with a vowel. Okay. Return an array answer of size queries.length, where answer of I is the answer to the ith query. Okay, for any word, it takes over one time to figure out if it starts and ends with a vowel. It's just going to be a bunch of trues and falses. Is there a DP way to... okay. Return an array of ans of size queries.length, where answer of I is the answer to the ith query. Note that the vowels are A, E, I, O, U. Okay. Here we'll say... So here we'll say is valid. We'll have a function called isValid. Def is valid, self comma string here. We'll say, are all the strings and words guaranteed to be at least 2 in length? If it's just one vowel, I'm guessing that's okay. Okay. We'll say, return string in self.vowels equals A, E, I, O, U. Return string of 0, self.vowels, and string of -1 in self.vowels. Okay. Now we have an isValid function. Cool. And, okay. Both inclusive. Okay, for something like this, can't we just we can just do prefix sums, right? If I just count up to like an index I, yeah, so if I count from an index 0 to I, the number of strings that are valid, then it's like, okay, so if we do something like prefix sums, so here, okay, let's do prefix sums is equal to this. Here we'll say current streak or current streak is equal to 0, or count is equal to 0. For word in words, count plus or equal to self.isValid word, and prefix sums dot append word. Here return, what do we return? An array, and here we'll do print a string prefix sums equals. Okay, let's run that. That's not what I want. Dot append count what I want. Okay, so here ABBA is correct. So yeah, up to index 0. Yeah, so prefix sums of I equals sum of self.isValid word in words up to I inclusive. Okay. So yeah, so we have this one. Yeah, so this doesn't start and end with a vowel. This does, so now it's 2. This does, so now it's 3. This does, now it's 4. Okay. And now what we want is words from, really what we want to say is 0 to I. Since to find. Notice that for any, so we go to j, prefix sums of j, prefix sums of I is equal to self.is valid word for word in equals this I duck minus uh, 0 to j equals this 0 to I plus from I to j, and then obviously we carry the same minus equals from I to j. There we go. So that's essentially what I'm trying to show. So yeah, so this is just a prefix sums problem. Here we can just do, or actually we can just do it. Yeah. Answer is equal to this for L, comma R in queries. We'll do answer equals prefix sums of R minus prefix sums of L if L greater than 0, L 0. So this is just a typical pattern that we do in many of our videos. Okay. Okay, let's run this. Wrong. Well, because we gotta return ants. Okay. Let's see. Wrong. Why is that? Oh, ants dot append answer. Okay, but here we get it wrong. There should be -1, right? Yeah, that should be -1 because we want to include L. Okay, there we go. Okay, so now we can get rid of this if printf statements. Here we can just do this. Yeah, actually we have that as in our comments, so we might as well keep it that way. Self.vowels, there we go. But this we can definitely just move towards the top, just so that's a bit more clear. There we go, bada bing, bada boom. Okay, so let's run this again. Perfect, all right, let's submit. And there we go, bada bing, bada boom, completion streak 170 days, consistency is key, see you tomorrow. Okay, nice. This is just a nice old typical prefix sums problem, so nice. Okay, so I guess that's pretty much all. So as always, in all my videos, I do a quick recap if I was able to solve the problem. So for this one, again, just a prefix sums problem, I guess. Essentially, we're given a zero-indexed array of string words and a 2D integer array of integers queries. So basically, it's like each query will be a pair of integers, right? So it's like, 0, 2, 1, 4, 1, 1, blah, blah, blah. And essentially, we have a bunch of words. And these two numbers will essentially represent indices inside of words. And we want to return, okay, between this index and this index inclusive, how many of the words have they're words starting with a vowel and ending with a vowel, right? Where the vowels are A, E, I, O, U, and not Y, right? And so essentially what I did is like, okay, let's keep track of prefix sums, of, from index 0 up to index I, how many words have a string that starts with a vowel and ends with a vowel, right? So essentially I call this is valid. So it's like, I have an is valid function that essentially takes in a string, or I should really make this take in a word, right? So maybe I change this to word and change this to word here. And essentially it's like, okay, given a word, get its first character, and if it's in self-vowels and its last character is in self-vowels, then it's a valid word, right? I.e. it's like, it starts with and ends with a vowel, right? And so essentially what I did is like, prefix sums. From the very beginning, we have 0 words that start and end with a vowel, and then I'm essentially going to loop over every single word, and every time I see a new word that is essentially valid, right, starts and ends with a vowel, I'm going to augment my count, right? So here I'm plus or equal by a boolean, sorry. When it's true, that's essentially going to be +1. When it's false, that's essentially going to be +0. I'm just kind of abusing Python notation here. Essentially, I'm going to increment my count every single time I see a valid word, and then every single index, because every single, the very first word that I look at will be the word at index 0, word at index 1, etc., etc., etc. I'm going to keep appending, like, hey, it's going to be, I'm going to append the new count, right? So the very beginning is 0. Every time I see a new word that is essentially valid, I'm going to augment my count and then put that into my prefix sums array. So essentially, prefix sums at index I will essentially be the number of valid words from index 0 up to index I inclusive, right? That's just the idea behind prefix sums. And then a typical pattern that I use with prefix sums is essentially, like, one nice thing that you can do with prefix sums is essentially, with prefix sums, you can do O of n work to essentially be able to compute the subarray sum of the sum of any subarray in constant time. And the way that you do this is essentially, if you want, let's say you only care about sum. In this case, we're treating it as a sum because it's like 1 is essentially if it's valid, 0 if it's false, blah blah blah. But if you had a typical array and you wanted to do the sum of any subarray from any index I to any index j, essentially what you can do is compute prefix sums from, like, the sum from index 0 to index I for any I, which is obviously very easy to do. You keep you start off with 0, and every element you essentially add its value, right? It's just that in this case, the values happen to be 0 and 1. 1 if it's a valid word, 0 if it's not a valid word, right? But otherwise, it's like, if the numbers were anything, you can make them anything, right? It's like if words was, an array of integers, and each integer had a value, you could essentially, like, take that value and put that as a new subarray sum and keep adding that over and over and over. It's just that here we're treating words as an array of integers, where the integers are, quote unquote, for each word, it'll be a 1 if it's a valid word, or a 0 if it's not a valid word, with a word being valid if and only if it starts and ends with a vowel, right? And so using that idea, essentially it's like, okay, we want the subarray of any we want the sum essentially of any subarray from any index I to any index j, right? Or any index li to any index ri, right? Why do we want this sum? Because essentially this sum will essentially be the sum of these zeros and ones, where ones is essentially if it's valid, zeros if it's not. So if we get the sum using this metric of any subarray in words, we essentially get the count of the total number of words that are valid, right? Which is exactly what we want. And the way that we do this essentially is like, okay, since we know that for any index I, right, I'm able to just quickly look up prefix sums of I, gets me the count of, valid words from index 0 to index I. Well, if I do prefix sums of index j, I can subtract from that wait, so prefix, this should be I minus 1. Sum of this minus this of I minus 1, then yeah, we can split up. So now we know that, okay, this is essentially my proof that I kind of wrote down here. So for any index I, let's turn it equal to j. Here, like, we're going to take this for granted, right? Prefix sums of I is equal to sum of, each word's value, which is either going to be 1 or 0, whether it's valid or not, for essentially every word from index 0 to index I, right? And this is just very, simple the way that we do it. We start off with a count of 0, and for every single word, we're going to augment our count with that word, whether it's valid or not, plus or equal to 1 or 0, and then, keep appending that count over and over and over. That way, it's like, for any index I, we know that prefix sums of index I is equal to the number of valid words from index 0 to index I, right? So now abusing this property, right, we say, okay, if I take, for any two indices I and j, prefix sums of j minus prefix sums of I minus 1. By the way, if I is equal to 0, then it'll just be 0, right? Because if I is equal to 0, that essentially means you want from 0 to j, which you already have by looking up prefix sums of j, right? So you just subtract 0, right? So that's a minute caveat. But otherwise, essentially, if I do prefix sums of j minus prefix sums of I minus 1, essentially what I get is the sum from 0 to j from this guy minus the sum from 0 to I minus 1, right? Now I can split the 0 to j into two parts, right? I can essentially say, hey, this is like going from 0 to I minus 1 and then continuing onwards from index I all the way up to index j, right? Because if I want the sum of, all the words, whether they're valid or not, from index 0 to index j, it's essentially like getting the sum from index 0 to index I minus 1 and then from index I all the way up to j, right? So essentially it's like, if I'm going to do the sum of all the numbers from 0 to j, it's like taking the sum of all the ones from 0 to I minus 1 plus the sum of all the ones from I to j, right? Again, like, I don't know what the word is. It's like addition is cumulative. I don't know what the associative, is that the word? I don't know what the proper mathematical term is, but like obviously it's like, if you have a plus b plus c, it doesn't matter whether you do b plus c first and then plus a, or like a plus b and then plus c, it doesn't matter the order in which you do addition, right? So here's like we can choose to sum up, the validity of the words from index 0 to I minus 1 inclusive, and then from I to j inclusive, right? So essentially we can split 0 to j into 0 to I minus 1 and I to j, right? But remember, we're still subtracting by 0 to I minus 1 here, right? So here I should make a quick update. But here, if we have the sum of the validity of each word from index 0 to I minus 1 minus the very same sum of, all the validity of all the words from 0 to I minus 1, essentially these two terms cancel out. And the only term that we're left with is this, which is the sum from I to j, right? Which is exactly what we want, right? Because the sum of the validity of the words from index I to j inclusive is essentially the count of the number of words from index I to j inclusive that are essentially valid, i.e. they start and end with a vowel. So this is just like, a little nice trick with prefix sums that I often use, I think, inside of the weekly LeetCode contest, where it's like, okay, if you have, an array and you care about, subarray sums from any index I to index j, essentially you can do O of n work to essentially build the prefix sums from any index 0 to any index I, and then write yourself a little helper function like this. Here in this case, it's like, for any index L and R, just prefix sums of R minus prefix sums of L minus 1, right? Remember, it's I minus 1 in this case, and so on. And that's if L is greater than 0. If L is equal to 0, right, then think about it. If L is equal to 0, then that means you want 0 to R, which is already what you have in prefix sums, right? So prefix sums of R is implicitly 0 to R. So if if L is 0, then in that case you just do 0, so that way you subtract 0 because prefix sums of R is already, from index 0 to R, right? So that's the only special case. Otherwise, if if L is greater than 0, then that means you want to kind of like subtract those beginning values at the very beginning. So that's why we do prefix sums of L minus 1, because again, that gives us our little sum that we talked about, right? Essentially using that notion, and that way it's like, for any pair of L and R in constant time, thanks to our prefix sums array, we're able to essentially get the sum of any subarray between any two indices L and R, or any two indices I and j, right? So it's just a very little powerful trick with prefix sums that you can always do when you care about subarray sums. In this case, we do, just because we treat words as zeros or ones, whether or not they're valid or not, right? But typically, whenever you care about, subarray sums, a good thing to do is essentially use prefix sums to do O of n work to compute prefix sums, so that way you can get the sum of any subarray from any index I to any index j of any array in constant time. Do O of n work to essentially get the subarray sum of any index I and j, which usually, if you didn't have prefix sums, you'd have to do O of n work every time, right? So if you wanted every single, subarray sum, then it's like, now it's like, you can go over all n squared many of them and do O of 1 work instead of going through all n squared many and doing O of n work, right? Which would lead you to O of n cubed work. It just helps you knock down a degree on the big O runtime there at the end. So prefix sums, just a very nice and beautiful idea. I did even look at the constraints. Yeah, so the constraints are like 10 to the 5, so you probably actually cannot even do this problem without doing prefix sums like that. It's just a nice, convenient. Honestly, this is probably one of the most important LeetCode problems that you should solve in case you don't know how to do it, just because this is a very, very, very powerful trick. It comes up a lot inside of the weekly LeetCode contest that I do. This is just a very nice, powerful trick of prefix sums that I actually didn't learn in college. I actually learned this doing the daily LeetCode challenges here. I didn't know about prefix sums being a thing until I started doing these daily LeetCode challenges. So hey, there you go. The more you know. These turns out these are actually helpful in helping me learn things, right? But otherwise, the rest of the code here is very standard, right? So it's like, we have a bunch of vowels, we have an isValid function, we build up our prefix sums so that we essentially get the count of valid words between any index 0 to I for all I, and that way we essentially leverage that idea so that way whenever we loop through the queries, we do this O of 1 work over here that we know will give us the sum of any subarray where we treat every single word as 0 or 1 depending on whether it's valid or not. So that way whenever we do such a sum of any subarray, then we essentially get the count of valid words inside of that subarray from L to R for every single query, which is exactly what we want, right? We want the number of words that start and end with a vowel. Essentially, that sum of zeros and ones will essentially be the count of words that are valid, i.e. words that start and end with a vowel exactly as we want. So essentially, for every single query, we just compute that as our answer, append that to our answer array, and at the very end, bada boom, bada bing, bada boom, we just return that as our answer, and there we go. That's pretty much it. So we can solve this one more time if we so choose, now that I updated a few things in the code. And we can see, okay, so it seems like, I'm a little bit inefficient. Maybe I could do some things a little bit better, right? Maybe it's like, I can take this over here, right? And, instead of this, maybe I just do count plus or equal to word in vowels and vowels. Yeah, also maybe I can make this, a set, just, because why not, right? So it's like, some of this stuff may help me go faster. Right, so now maybe I can submit this. Okay, and there we go. We're now at 15 ms, 93.12%. So yeah, so it's just like, it's O of 1 time stuff here. That doesn't really matter too much in terms of big O complexity, but sometimes in these LeetCode challenges, they make all the difference in terms of making your code a little bit more efficient, right? So here's like, I wonder if like, if I still did this, is it still just as efficient, right? If I resubmit this, or is there too much overhead in just having an extra function here? Yeah, so there's a bit of overhead, right? So yeah, so we can get rid of this. We can get rid of this. Yeah, I might as well leave the isValid function just so that's understood what's going on in here. Right, self.vowels equals vowels if anything, right? So here's just like, count plus or equal to self.isValid word, right? And then here I can comment this out, here I can comment this out, and there we go, right? So it's just like it's understood what I was trying to do here. And then here's like, I can just return an array, right? And here this will be L, R in queries, right? So here I can just do something like this, right? And then just submit that, and that way it's like, we just get it to be like as blazingly fast as we possibly can. There we go, we just get back to that 93.12%. But again, these are things that don't matter. This is just me changing, minute O of 1 stuff just to make it a little bit faster for the LeetCode. But otherwise, the previous solution that I had is just as efficient and in terms of big O runtime complexity, right? This is an O of n O of nm algorithm, where n is like, the length of words, and m is the length of queries, because at the very beginning we do O of n work to essentially build the prefix sums, so that we can then use that to do constant work for any subarray sum, and then we just gotta loop over through every single queries and do that O of 1 work. So this is O of, so m times O of 1 work is O of m work, so O of m work over here, O of n work over here. Oh, I guess it's not O of n times m, it's O of n plus m, sorry. So this is actually a linear running runtime algorithm, right? So it's like, between n and m, take the maximum one, and it's just that running time complexity, right? So, or, in more technical terms, it's O of n plus m, right? And there we go, bada bing, bada boom. So hopefully that solution makes sense. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate it if you left a like or a comment. But otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.